here's another example for us to work through. So I'll let you pause the video and read it if you'd like. But the idea is here that we have a dock, right? And at 2 p.m., one boat leaves and heads due south, so leaves at 2 p.m. and it goes at a rate of 20 kilometers per hour. Okay, and then there's another boat that has been heading due east. Okay, so it's heading due east at 15 kilometers per hour, right? And then it reaches the dock at 3 p.m. Okay. So then what we want to know is at what time the boats were closest together. Okay, so we're looking kind of at the hypotenuse between them. Okay, so right triangle, foreshadow, foreshadow, foreshadow. Okay, but the idea here is that if we think about the time, okay, so t is time, okay, we're going to say that this is this length here that we're looking at is going to be sometime between 2 p.m. and 3 p.m., right? Because otherwise, before then, the one boat would have been at the dock, and then after that, the other boat will be at the dock, okay? 3 p.m., okay? And so what we're going to do is just say that t is somewhere in the interval 0 to 1. Again, it is open. We're just going to say 0 is 2 p.m., would correspond to 2 p.m., and 1 would correspond to 3 p.m. Okay, so then how does that translate into our exercise here? Okay, well, we do have the triangle. Okay, so I'm just going to say, okay, here's the dock, and there's the other boat. Okay, we want to look at the distance between them. Okay, this is x and this is y, right? But if we think about it carefully, we're actually going to be representing x and y in terms of time. In fact, if we think about x in terms of time, x would be distance, right? Distance is rate. I should actually write it out. Distance is equal to rate times time, right? So I can actually represent x as the rate, which is the speed, so in this case be 5, and then times time, well, it would in this case, it's going to be 1 minus t because at time 1, we want that whole thing to be 0 because it's the distance it would be from the dock, right? So when time is 1, it's further away, okay? Similarly, if we represent y in the same manner, the rate is 20, and we're going to say that it's going to be 20 times time, which is just t, because at 2 p.m., the boat is at the dock, so therefore its distance from the dock is 0. Okay, so we're actually going to use these, and these are going to be our constraint equations. Okay, now we do have a right triangle here, so ultimately the equation that we're being governed by is the Pythagorean theorem. So d squared is equal to x squared plus y squared, but then I'm going to use those constraint equations and substitute those in. Okay, so x here is going to be 15 times 1 minus t all squared plus, and then 20t all squared. Okay, and if you simplify this out and just solve for d, it could be easier to leave it as not this, as not a non-square root, and just leave that as squared, but you end up getting 625 t squared minus 450 t plus 225 after you FOIL it all out and collect terms. Okay, so now this is our function. It is a function of time, t, which is good. That's what we want. And now I need to go through and find the critical points. I don't have any absolute, or I don't have any endpoints to consider because I'm on an open interval once again. Okay, so d prime is going to be 1/2 and then 625 t squared minus 450 t plus 225 to the negative 1/2 power, and then all of that times 1250 minus 1250 t minus 450. Okay, and this is equal to 0, right, for the critical numbers, and this whole denominator would wipe out, and I just set the numerator equal 0, so this would give me 1250 t minus 450 is equal to 0, and if you solve this, I got 0.36 hours. Okay. All right, so now we believe that this might be a maxima or minima, okay, and given the language and the problem, this is probably going to be a minimum, but we need to verify. So do we want to do second derivative or first derivative test? Okay, either one. We've done second derivative in the first ones. This one, I'm actually going to pick the first derivative test only because the second derivative is incredibly nasty, and working through the algebra there is going to probably be the death of me. Okay, so instead what I'm going to do is make a little sign chart. Okay, I'm going to do d prime and d, and I know that t is on an interval 0 to 1, okay, non-inclusive, and I have my critical number rather, of 0.36. Okay, so what I'm going to do is look at d prime of, say, 0.25, and then d prime of 0.5, and calculate values there. Okay, in this interval, I do end up getting that it's a negative, and in this interval it is a positive, meaning that d as a function is decreasing in the first interval and then increasing in the second interval. Okay, because of this behavior, I'm going to say yes, that there is a local min at t is equal to 0.36 by the first derivative test. Okay. All right, so then what does this mean for me? Okay, ultimately, this means that the two boats were closest together at t is equal to 0.36 hours. Okay, but now that would be after 2 p.m. Okay, or if I actually calculate that out in terms of a clock, it ends up being at 2:21:36. Okay, so 21 minutes past the hour and 36 seconds. Okay, which that was kind of fun to compute, so I encourage you to maybe try that on your own. But the overall idea here, we're still optimizing, but sometimes the constraints are a little hidden. Okay, so getting the diagram drawn made me realize, yes, I do need a triangle where the side lengths of that triangle would be x and y, but I needed to represent that distance for x and y in terms of rate times time, because I don't know how far it is, but I do know certain information about how fast it's going and when it reaches the dock.